Hello everyone, welcome to another session of switch mode power supply repair training. In this session, we will continue discussing the issues and failures of switch mode power supplies. So stay with me. Another problem that a power supply may encounter is that it turns on, but the output voltage, such as the main 12 volts or 5 volts, are either lower or higher than they should be and are not suitable. The reason for this problem is the failure of capacitors and inductors in the secondary circuit. Since the capacitors and inductors in the secondary circuit, which is the final output voltage circuit, play the role of filtering and stabilizing voltage and current, the failure will lead to instability in the power supply's output voltage. As a result, the voltage either exceeds or falls short of the normal levels. If you notice that these voltages are higher than usual, but the power supply continues to operate and does not shut down, you should also suspect the control circuit. This is because it didn't detect the overvoltage and didn't shut down the power supply. If the overvoltage protection circuit is working correctly, it will cut off the power supply and shut down the power supply when it detects an overvoltage situation. Now, what does this overvoltage protection circuit look like? Here you can see several capacitors and supply voltage to the switching IC, which monitors the voltage. What you need to do is to test capacitors in this section. The resistors are not our primary concern. The capacitors are more important. Test the capacitors, and it is even better to replace them. Also replace the switching IC, as it might not be functioning correctly, resulting in incorrect voltage and no response from the control circuit. Therefore, in addition to replacing the capacitors and inductors in the secondary circuit, you should also replace the switching IC. Furthermore, the absence of certain voltage, such as the -5 volts on the white wire or the +5 volts on the red wire, indicates that these components in this section are faulty. By testing these components, you can identify the defective ones and replace them to resolve the issue. In this case, the regular diodes in the secondary circuit, along with the capacitors and inductors, are the components that may have failed and need replacement. The job of the inductors is to stabilize the current, and when the inductors fail, the current in those wires will not be maintained. Similarly, when a capacitor fails, the voltage will be problematic. So, when you observe that a capacitor is faulty, or in other words, the voltage is not suitable, first replace the capacitor and then test the inductors. If the inductors are fine, there is no need to replace them. However, if you notice that the inductor terminals are not connected, no continuity, and the inductor does not beep, it means the inductor is faulty and needs to be replaced. But in most cases, it is the capacitor that needs replacement, as inductors rarely fail. The capacitors in the secondary circuit tend to fail more quickly. The next issue is when the power supply is plugged in, the fuse blows, or if it is connected to the test lamp lights up. In such cases, the fault is due to a short circuit and failure in the primary circuit. Components that cause a short circuit in the primary circuit are usually the switching transistors or the bridge rectifier diode. In this context, we have two transistors in the switching circuit and one transistor in the VSB circuit. When these transistors fail and create a short circuit, it results in the test lamp lighting up when you plug in the power supply. Or if the bridge rectifier burns out, it also creates a short circuit. When you connect the power supply to the electricity, the fuse will blow, or if connected to the test lamp will light up. Therefore, when faced with such a problem, first test the bridge rectifier and then test the 3 transistors. If the bridge rectifier is faulty, replace it. If it is in good condition, test and replace the transistors. You should start by removing all 3 transistors from the board and then test them. Place the good transistors back into their original positions, but replace any that are faulty. Remember that whenever you need to replace a transistor, you should also replace the low ohm resistor and the diode associated with it. In most cases, if a transistor has burned out, the resistor and diode next to it are also damaged. Failing to replace them can result in the new transistor burning out again, and the power supply will not work correctly. The next problem with the power supply is when you open it and see that the input fuse is blown. As mentioned, there is a glass fuse in the input path. The action you need to take is not to immediately replace the fuse. Why? Because a blown fuse indicates a short circuit inside the power supply, and simply replacing the fuse will not solve the problem. In this situation, you should check the bridge rectifier, transistors, resistors, and diodes associated with the transistors. If they are all in good condition, then you can replace the fuse. Otherwise, you need to replace the faulty transistor or other components in the primary circuit and then replace the fuse. Another problem the power supply may face is that it turns on and all voltage and outputs are good according to the power tester, but it cannot power on the motherboard when connected to a computer. In such cases, it's better to test the power supply with another computer, as sometimes the motherboard may be faulty. If the motherboard or other components like the hard drive are faulty, the computer will obviously not work. But if you test it with another computer and find that the same thing happens and it cannot power the motherboard, then the problem is with the power supply. But why does the power tester show the power supply as healthy while it doesn't work in practice? The issue lies with the output currents. The power tester measures only voltage, not the output currents. In 90% of cases, the problem is related to the inductors and capacitors in the secondary circuit. Even if the capacitors appear to be in good condition, it doesn't mean they are functioning correctly. In such cases, you should replace the capacitors and inductors. Since the function of inductors is to stabilize the current, if they are faulty, they won't be able to provide the necessary current for the computer to operate, even if the voltage is correct. Now, if you have tested the secondary circuit and found no issues or have replaced any faulty components, you should check the starts-up capacitors. These capacitors are located in the primary circuit and you need to test and replace them if necessary. If the secondary circuit has no problems and the power supply turns on correctly but shut down when trying to start the computer, it is likely an issue with the inverter section of the power supply circuit. The main components of the inverter are these start-up capacitors. Transistors do not partially fail. They are either completely functional or completely burned out. It is the capacitors that might be partially failing, causing the power supply to be unable to power the motherboard. Regarding the capacitors in the secondary circuit, you can replace them with ones that have a higher capacitance and voltage rating than the original capacitors. For example, if one of the capacitors in the secondary circuit is 2 1200 microfarads and 16 volts, you can replace it with the 3300 microfarads and 20 volts capacitors without any issues. However, you should never use capacitors with a lower capacitance or voltage rating than the original ones. Additionally, the new capacitor should not have a much higher voltage rating than the original. For example, in the original capacitors is 16 volts. You shouldn't use a 50 volt capacitor. Instead, you can use capacitor with a maximum voltage rating of 25 volts. Another issue that might arise is that all components in the secondary circuit might be functioning properly, and the start-up capacitors in the primary circuit are also in good condition. Yet the computer still shuts down. In this case, no component in the power supply might be faulty, but rather it might be experiencing a phenomenon known as cold solder joint, meaning the solder has aged and needs to be refreshed. In this situation, the solder on the component leads has either deteriorated, become brittle, cracked, or developed oxidation. Consequently, it no longer establishes a proper connection as it initially did. In this case, we need to resolder the component leads, essentially refreshing the solder. This involves removing the old solder using a desoldering pump and then resoldering the joints. After resoldering, clean and wash the back of the circuit board using a brush or toothbrush and thinner, preferably 20,000 or at least 10,000 grade. After completing this step, you should see that the power supply functions correctly. Up to this point, you have learned how to troubleshoot switching power supplies using a flowchart, and we have covered significant faults. For better understanding, it is recommended to watch this video and the previous one multiple times. If you have any questions, please ask them in the comment section and we will respond. With practice and repetition, you can troubleshoot and repair a power supply within a week, gaining the necessary skill in this area. The principles of switching power supply are consistent, and once you are proficient in repairing these, you can easily repair other power supplies, such as server power supply or minor power supplies. The most important aspect of repairs beyond practice and repetition is experience. This practice and repetition will provide you with the experiences that will help you quickly identify and solve problems. That's it for this session on switching power supply repairs. If you have any question before the next session, please ask. Don't forget to like the video and make sure you've subscribed to the channel. We would appreciate it if you could share this channel with your friends so that it can grow and develop quickly. Until the next session, please take care, see you soon, and bye-bye.